Okay, these notes are combined of everything in 7.5 that we did in class in the 3 days that we took notes. So the first thing we went over was solving exponential equations, and there's two methods. Sometimes you're going to have to use one of the methods, sometimes you can use either one. The first method we're going to go over is if you can get both sides to be the power with the same base, meaning if the bases can get to be the same, then the exponents must be equal to each other. So if b raised to the x is equal to b raised to the y, then x is equal to y. So for this one, both 16 and 8 can be written as a power of 2. 16 is 2 to the 4th. 8 is 2 to the 3rd. The power to a power, 3x and 4, you multiply, so that becomes 2 raised to the 12x is equal to 2 raised to the 3rd. So now that the bases are the same here, you can make the exponents equal to each other and solve. So divide by 12 and reduce, and x is equal to 1/4. Okay, so for this one, I can't do that. I can't get 15 and 285 to be a power of the same base. So the way you're going to do this is you're going to solve it using logs. And it's in exponential form, so to solve it, we're going to change it to log form. So log base 15, keep the base of 285, go away, come back, is equal to 3x. So now in the calculator you can find the value of log base 15 with 285. Remember, if you're using a scientific calculator, it only has base 10, so you got to use the change of base, and it becomes 2.087 and so on. Don't round it quite yet, keep it in the calculator because you need the exact value. Divide by 3 and your answer is x equals 0.6958. I'm rounding to the nearest 10 thousandths. That's going to be the directions in the work. So that's 4 decimal places. This was 0.69576. This 6 rounds that up to an 8. Okay, so for this one, this is an exponential function. I can't get the bases to be the same. It's not going to be that big. If you can, it's going to be more obvious. So I need to use log form. So I change it to log base 13 of 865,792. Now I'm going to put that in parentheses just because it's so long, is equal to the exponent of 2x plus 1. So do this in the calculator, and you get 5.33. Again, keep it in the calculator because I need to round to the nearest 10 thousandths. Subtract 1, that's going to be 4.33 and so on, and divide by 2, and x is equal to, or it's actually approximately equal to, so because I'm rounding, 2.165. It's really 16504. Well, that 4 rounds the 4th decimal, stays at a 0. So if you put that, that's fine. If not, that's fine too. Okay, this is an example where you have to solve this by getting the bases to be the same. If you have variables in both exponents, you have to get the variables to be, or the the bases to be the same in the same power with the same base. So 5 can't be simplified, but 25 can be written as 5 squared. Now that 5 squared is raised to 3x minus 5. So what you're going to do with these two, just like before, is multiply them. But when you multiply them, you need to make sure you distribute. So you get 2x, I'll write it this way. 5 raised to the 2x is equal to 5 raised to the 6x minus 10. Now the bases are the same, so you can set the exponents equal to each other. I'm going to solve for x. I'm going to try to keep the x positive, so I'm subtracting 2x, adding 10, and I get 10 is equal to 4x divided by 4. Doesn't go in evenly, but it can reduce, so x is equal to 5 over 2. Okay, so this is a log equation now where the x is in the log, and since it's in log form, I need to solve it. I'm going to change it to exponential form. Remember, this is a common log because there's no base shown. So to change it to exponential form, I have that 10, which is the base in the common log, raised to the second is equal to 4x minus 3. 10 squared becomes 100. And now you just solve for x. Add 3. 103 is equal to 4. X divide by 4, and x is equal to 103 over 4, which becomes 25.75 as a decimal. Okay, the second example is a little bit different because it has two separate logs. And you have to remember your log properties from 7.4 in order to do this. When two logs are being added together, to make it a single log, you're going to multiply what's inside each of them. So I have x times x minus 3. Because you need to have it as one single log before you can solve it. So you distribute x squared minus 3x, that's inside the log. Again, it's a common log with the base 10. So now I can change it to exponential form. 10 raised to the first is equal to x squared minus 3x. To solve this, because it's a quadratic, get everything on one side, and you're going to have to factor. Okay, so this factors into x minus 5 times x plus 2, which means I have x equals positive 5 and negative 2. Before you write your final answer, though, you need to check, because whenever there's a quadratic, that can produce extraneous solutions. So to check it, I'm going to first check x equals 5. You plug it in. So log, when I'm plugging it in here, up top, 5 minus 3 becomes 2, plus log of 5. Now if you type each of those in the calculator, add them up, it does become 1, so that one works. When you plug in negative 2 minus 3 becomes negative 5. This one does not work because there's negatives inside of the log. The extraneous one comes from the negatives inside the log. So my solution here is only x equals 5. Before you change it to exponential form, you got to remember to get the log by itself first. Okay, sometimes you're going to have to do other operations, adding something, subtracting something, dividing by something. So remember that, and then your log properties also. So here I have 10 raised to the negative 1 is equal to 3 minus 2x. 10 raised to the negative 1 becomes 1 over 10. Remember, because a negative exponent moves to the denominator. Now, to solve this, it's going to be difficult with this fraction here. So I'm going to get rid of that fraction by multiplying by its denominator, which is 10. 10 times 1/10 becomes 1. 10 over 10, which is 1. I got to multiply it all the way through, though. Okay, and now I can solve it. Subtract 30. Negative 29 is equal to negative 20x. Divide by negative 20. And x is equal to positive 29 over 20, which becomes 1.45. Other scenarios where you may get a fraction from a negative exponent, if it's only one fraction on each side of the equation, you can solve by cross multiplying. Okay, here's some U-try problems. Remember, the first one is meant to be done by getting the bases to be the same, but you could solve it with logs. Try to do it with the base, getting the bases to be the same with the same power. Number 3, you have to get what is being raised to that exponent by itself first. Okay, so there's one step before you change it to log form. Number 4, remember the log properties. When the two logs are being subtracted, you should divide what's on the inside of the log. Okay, so you got to get those to be one log first. Okay,